A single meteorite could instantly wipe out all dinosaurs on Earth, leaving no trace. Only an unimaginably huge crater remained. This place is the Yucatán Peninsula in Mexico. Beneath the surface lies a massive impact crater called Chicxulub. You might be curious. Since there is such a huge crater, what about the meteorite that hit Earth? What is strange is, no one has ever seen any of its debris. Yeah, it is that absurd. A space rock that might have ended the dinosaur era just vanished as if out of thin air. No one has ever found its main body. Where could such an important thing have gone? Some guess it might have vaporized and exploded completely on impact with immense power. Most of the fragments have long since turned into gas or particles, dispersed in the atmosphere. But others believe it might still be hidden somewhere on Earth. Now, scientists have finally found a possible clue, but truly getting close to it is extremely difficult. Rewind to 66 million years ago, a massive asteroid crashed into Earth, marking the end of the Cretaceous period. It struck what is now northern Central America, or Mexico. This impact triggered a global heat wave, followed by years of severe winter. The entire Earth plunged into utter chaos. The consequences of this catastrophe were devastating. Over 60% of life went extinct. Not just ground dinosaurs like T-Rex and Triceratops, but also pterosaurs in the sky and mosasaurs in the water, almost vanished overnight. This impact not only ended the age of dinosaurs, but also indirectly led to the rise of mammals. It finally set the stage for humans, including you and me. Recently, scientists finally found the notorious meteorite's possible origin and its final resting place. This is not just some rock drifting near Earth. It could have come from beyond Jupiter's orbit and then come hurtling directly towards Earth. We will get to that later. First, let us look at the details of that devastating impact. When the meteorite hit Earth, rocks from deep within the crust were blasted away. They shot up into the sky, as high as 25 kilometers. Impact. It also formed mountains taller than the Himalayas, rising around the crater's rim. The extinction-causing asteroid was about 10 to 15 kilometers across, smashing into Earth at nearly 20 kilometers per second. The impact angle was about 60 degrees, just right to vaporize the most rock, and the ideal angle to throw it into the atmosphere. This also led to a large amount of sulfur gas and dust being ejected into the air, blocking out the sun. The Earth plunged into an impact-induced winter that lasted 15 years. Dinosaurs had ruled the Earth for nearly 200 million years at that time, but they could not survive this catastrophe. Some scientists believe the asteroid was just the last straw. Dinosaurs were already on the brink of extinction before that, but regardless, the vast majority of dinosaurs eventually went extinct, and the very few survivors may have evolved into today's birds. To figure all this out, scientists spent decades. In the 1970s, researchers at a Mexican oil company first discovered this massive crater. Later, scientists gradually realized the connection between this crater and the Cretaceous extinction. One of the key clues was the ancient fish fossils found there at the time. Imagine the moment the meteorite hit Earth. The immense shockwave released directly blasted rocks from deep within the Earth's crust. Even some rocks were turned into glassy spikes, spirals. These small spiral particles, called ejecta, are actually molten material formed after rapid cooling. What is even more outrageous is that some of these jets were actually stuck in the gills of the fish at that time. Later, when scientists studied these fish fossils, they discovered a startling clue. By analyzing the growth lines in the fish bones, just like the annual rings of a tree, they determined that this catastrophe occurred in the northern hemisphere spring. The impact left traces that are more than just geological deformations. For decades, scientists have been studying the impact site, hoping to uncover more truths. Through residual chemical information, fragments of that meteorite is now hidden beneath the Yucatán Peninsula, covered by thick layers of rock and sediment. So they turned to chemical signatures in the rocks, especially those from the end of Earth's Cretaceous period. They eventually found that the meteorite came from beyond Jupiter's orbit, and it was not just any meteorite. It was one of 6 ancient bodies called carbonaceous chondrites, one of the most primitive rock types in the solar system, likely formed billions of years ago. They also found another key clue, iridium, a metal that is extremely rare on Earth, but relatively common in meteorites. Scientists detected trace amounts of it in the rocks of the impact layer. This all but confirmed this visitor from outer space really did fly in from outer space. It was not a volcanic eruption or a comet. In 2016, scientists finally announced a major breakthrough. They launched a drilling project at the Chicxulub crater. The team successfully drilled over 1,300 meters beneath the seabed, collecting precious core samples. Those core samples actually contained the original granite bedrock that was impacted. These rocks were not only highly fractured, but also severely displaced, directly stacked on top of the sedimentary layers. This further confirmed the theory of a central peak ring forming after a meteorite impact. Speaking of this central peak ring, it is a ring of ridges surrounding the center of an impact crater. It is like a ring of mountains that bounced up after the impact. This structure, we have only seen it in super impact craters on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved case. NASA's moon missions also provided new discoveries. In the Oriental Basin on the Moon, the formation mechanism of the central ring is identical to that of Chicxulub. Scientists are paying special attention to this structure because they want to verify the simulation models of crater formation and also see this region. Could it be one of the earliest microbial habitats after the extinction event? Within minutes of the impact, granite deep within the Earth sprang up like liquid, forming a central tower 10 kilometers high. It then rapidly collapsed, eventually becoming the central peak we see today. Then, a mixed layer of rock and molten material covered it. Later, a tsunami brought a large amount of sandy sediment into the crater. Also in 2016, scientists during drilling also found a 10-foot core sample. It contained granite fragments and minerals filled with hydrothermal fluids. This means they have entered the structure of the central plume. Geologists from the University of Texas pointed out that they had long anticipated this plume structure would be a massive hydrothermal system, and the drilling has confirmed this judgment. Finally, the team successfully drilled to a depth of 1,335 meters, collecting a large number of well-preserved core samples. They also obtained a wealth of valuable data from the late Cretaceous period and completed the borehole scanning. Next, scientists from around the globe will spend time deeply analyzing these findings, attempting to answer some mind-blowing questions. Where did that meteorite come from? What did he really change behind the dinosaur extinction? Was it coincidence or a twist of fate?